Good afternoon, everyone. Do you hear me all right? Excellent. So welcome to the third day of AWS reInvent and welcome to my session. My name is Priya Ponnapalli and I'm a principal scientist and senior manager on the Amazon Machine Learning Solutions Lab team. And my team is a customer-facing team of data scientists. We work with AWS customers from very many different industries, from finance and healthcare to sports, and we help them with accelerating their machine learning adoption. And I lead our sports business vertical, and we love working with our sports customers. And we're seeing a big trend with sports organizations really embracing data and new technologies like IoT and machine learning. So in today's talk, I'm going to go over what the machine learning renaissance means for sports, and we'll take a look at Pro Football Focus as an opening story. We'll then look at what the machine learning opportunity for sports is through some case studies where we show how AWS is changing the game with our customers like the NFL, Formula One, and Major League Baseball. And finally, we'll go over how you can get started using machine learning in your enterprise. So machine learning, it's teaching machines, helping machines learn without explicitly programming them. So, it's a new paradigm where you give the machine the data and the right answers if you have them, and you let the machine learn the rules. And it's been around for about 50 years, but we're really seeing it disrupting multiple industries. For example, you're already using machine learning a number of times a day. Anytime you use your email and your spam filter, that's ML. Anytime you're watching movies on Netflix and you get recommendations, that's ML. And it's really, been spurred, this renaissance. It's been spurred by three key factors. So the first is the availability and accumulation of huge amounts of data. In sports, for example, with cars like Formula One cars, we have a ton of sensors gathering telemetry data. With football, we've got players wearing RFID tags, and we're capturing XY positions. We're capturing where the ball is and where all the players are on the field. So we have a ton of data. The second key pillar is the availability of compute, right? So for deep learning models, so deep learning is a subset of machine learning that's based on neural networks, and they need a lot of compute like GPUs. So the availability of compute has been another major catalyst. And finally, there have been some major advances in algorithms, some very fundamental algorithms like backpropagation. And all of this has really led to the machine learning renaissance. And it's hugely supported by the cloud. So the AWS cloud has, for example, S3 to support data storage. It's got EC2 instances and SageMaker to support the compute. And it's got a number of first-party algorithms built into SageMaker to really help the whole machine learning ecosystem. And let's see how our friends at Pro Football Focus and Chris Collinsworth, how they're using AWS's AI ML services to really analyze players from all 32 teams and over 60 colleges and uncover insights and new metrics that have really never been seen before. So let's take a look at how they do it.
If you are addicted to the game, which I think I'm addicted to the game, the passion of the study itself becomes really significant. There's always a real buzz at the start of football season.
PFF analyzes football in more detail than anybody else on the planet.
Things like our passing group is like the data is so much bigger than what my team can do with it. Our plan was, let's partner with somebody that can help us with the data.
The most important thing for us was to build a system that was seamless, so we moved our whole infrastructure into the AWS cloud.
We can now predict future performance based on the data of the past. With the machine learning and AWS, we're going to truly change the game.
So I love it, truly changed the game. Innovating the fan experience, it's really a top priority for sports organizations today. And, we're seeing a number of sports leagues and teams using AWS to reinvent the fan experience. There's Six Nations Rugby that's using our AI/ML services for predictive analytics and to give fans new insights into the relative dominance of teams. We've got NASCAR that's using a number of our AI/ML services. They're using Amazon SageMaker on over 70 years of historical footage, and they're building deep learning models for video analytics. NASCAR is also using our computer vision platform, Amazon Recognition, to automatically analyze video frames extracted from their video footage and tag it with metadata like the driver, the car, the sponsors, record the lap time. They're also using Amazon Transcribe to caption every word and timestamp every word in their video, and they're doing all this in real time and really enhancing the fan experience there. The LA Clippers, they're using AWS AI/ML with Second Spectrum, which is NBA's video tracking technology, and they've built a live augmented fan experience called the Clippers Court Vision. And Court Vision really transforms how we consume the game, and it puts fans in control. And then we have Swimming Australia, which is Australia's peak swimming body, and they are using AWS to optimize athlete performance at critical junctures in the race. So the machine learning opportunity in sports, it's really huge. We've gone from reactive post-game analysis to being a lot more proactive and predictive. So this can help coaches and teams make real-time decisioning. There's a lot of data that's coming on from these IoT sensors that's real-time. So, again, all the inferences that we're making, they've gone from delayed to real-time. And then there's a lot of also manual effort involved in logging events in sports, right? So, for example, logging level 1 events in soccer, like we have 6 people at the field recording goals and penalties and yellow flags and red flags, and we're starting to use computer vision systems to automate this process. So we're going from manual to automatic. And finally, we're going to much more visually rich graphics that transform the fan experience, both on television through broadcast and also through second screen experiences. So let's take a look at how we're doing it with some case studies with some of our customers. I'm going to start off with the NFL. So the NFL was the most popular television show in 2018. They had more than 15.8 viewers last year, and they have over 180 million fans worldwide. And the NFL has always tracked event data from the very beginning, but they're really using machine learning in a very expansive way to unlock the potential of all of their data and make it available to their coaches, their players, their fans, and everyone who loves the sport. So the NFL's next-gen stats, which is their tracking system, it's powered by AWS, and they track players' positions, their XY coordinates, they track the ball, and this is done through RFID sensors in the shoulder pads of players, in first down pylons, with the referees in the ball, and these RFID tags, they're transmitting location data every 10th of a second. So this amounts to over 3 terabytes of data every week, and the NFL is using Amazon SageMaker along along with this data to develop a whole bunch of real-time stats that, again, give deeper insights to fans. They help with game officiating. They help broadcasters and talent with their storytelling. Now, we have a pretty wide array of these stats, and I'm going to go over one of them. Let's take a look at pass completion probability, which we rolled out last year. So this is a machine learning model that can predict the likelihood of any pass from any receiver in any play to be completed. So this is a model that takes as input about 10 different features. So it takes things like the time to throw. It takes the distance between the quarterback and the nearest pass rushers. It takes the distance between the receiver and the closest defenders, and many more such features. And this was trained over 35,000 plays, collected over 2 seasons. And it's an XGBoost algorithm. It's one of the first-party algorithms that's built into SageMaker. So this model was trained and deployed on SageMaker, and it supports latencies of well under a second to be used in real time during game broadcasts. So let's take a look at this model in action.
Take a look at our next gen stats powered by all our pals at AWS, and we're going to go right inside the game here. Take a look at this completion for the touchdown. Doug Baldwin, 38 yards in the air, less than a yard of separation. But when you have the hands of Doug Baldwin and Russell Wilson, the completion probability 34%. Those guys do it more often than not. That has been some combination over the years, and now with Baldwin back in the lineup, they're starting to look like this offense should look.
So that's Chris Collinworth's voice over there, and then we have another fun video perspective of this play.
Russell Wilson is fearless, and AWS has proof. It's second and goal, and the only thing coming for Russell is an 800-pound pain brigade. He's forced to scramble like eggs in the morning, running crazy fast. Nobody is open. Catch probability is under 25%. And oh! Russell Wilson is a monster.
Rawr.
Next Gen Stats, powered by Amazon Web Services. AWS is how.
Wonderful. So we're continuing to roll out many more additional next-gen stats. The NFL is going to continue to roll out more in the 2020 season, and they're really working on some transformative use cases that use AI and ML that really push the boundaries of what's possible. And we have a new ebook that captures the NFL's machine learning journey. Its introduction is written by Michelle McKenna. She's the NFL CIO. And Matt Swenson talks about his team, the Next Gen Stats team's experience of working with the Amazon Machine Learning Solutions Lab to really build out all of these use cases and take them from idea to production. So I recommend you check it out. All right. So the next customer we're going to look at is Formula One. So Formula One, they're some of the fastest cars out there. I think 230 miles per hour, 5G cornering and braking, and they have over 500 million fans all over the world. They have races in 21 countries, and they have revenues of about $2 billion along with their teams each year, and a ton of mastery and skills go into these cars. Let's take a look. This one might be a little bit loud, so just watch out. So that was fast, right? In 2 seconds, that pit stop took under 2 seconds. In 2 seconds, they took the tires off, put new tires on, and the car is all ready, set, and go. And it takes a tremendous amount of teamwork to make that happen. And Formula One is also an extremely data-rich sport. So F1 Insights, which is Formula One's analytics division, analyzes and collects a lot of data coming from these cars. So they have 120 sensors on these cars that are collecting data, both from the cars and also that's telemetry data, and also from the track. And over 1 million data points move between the pit stop and the track. And up until now, it was only the teams that had access to it. And F1 Insights, for the first time, it's giving fans a look into these split-second decisions and strategies that these teams are making. So using all of this data, so data from telemetry, the tire compound, data about the drivers, and using Amazon SageMaker, Formula One is training new machine learning models that give these insights into these split-second strategies. So I'm going to go over 2 models today. The first is battle forecast. Overtaking, as you know, it's a critical and it's an essential part of Formula One racing. And what we've built here is a machine learning model that works on real-time data. So it's been trained on historical data, and it uses real-time data such as closing speed, the car positions, and where the cars are, what type of a corner it is, and it gives us the overtake difficulty involved in that battle. So let's take a look at this model in action.
So Verstappen has got a bit closer now to Valtteri Bottas. Charles Leclerc should be within striking distance of getting at the Red Bull in about 7 laps' time. But the overtake difficulty there showing that it's a little harder than 50-50.
Another very important aspect of Formula One racing is the pit stop strategy. So, pit stops is when a tire change happens, and at least one pit stop is mandatory in Formula One races. And when a driver and a team decides to take a pit stop and what kind of a tire they change can really win a race or lose a race. So we've developed a stat that predicts what the gap would be if a car were to take a pit stop, as well as the likelihood of an overtake after the pit stop. So here we go.
But what can Lewis Hamilton do on those medium compound tyres that he says he feels good on and are looking good in terms of the battle with Max Verstappen? At the moment, he's got about a 1 in 5 chance of getting past Max Verstappen, but the hard compound tyre takes a little longer to get up to temperature. Hamilton's nicely in the window, and that's chance of an overtake now about 13%.
So AWS is continuing to work with Formula One. We will be rolling out many more new stats as part of F1 Insights, and we're super excited about it. The next customer we're going to look at is Major League Baseball. Baseball fans, they're huge fans of statistics, and MLB, it ingests and stores over 17 petabytes of data each season on AWS. This is data from sensors and using LiDARs. And, one of the stats that we built using all of this data, it's called stolen base success probability. And what it does is it predicts the likelihood of a runner successfully stealing second base. And again, this happens in real time as well. Let's take a look at the stat in action, and then I'll give you a little more insight into how this was built out.
I don't know what pitch he's going to run on, but he's not there to stand on first base.
Well, he's forcing now Ottavino and the defense now to throw sliders. You have to focus on buys. Again, buys against the off-speed pitch this year has just been phenomenal.
That success probability takes into account Gore's speed, which he uses here without a throw.
Don't even bother.
So the way we built the stolen base success probability model is we took as inputs over 30 different features like the pitcher's time to home, the catcher's pop time, the runner's speed, the lead distance, and the game situation, the number of strikes, counts, outs, as well as a ton of historical data. And we trained a deep neural network, and this was deployed on Amazon SageMaker. And what MLB does is prior to each play, they ping this endpoint that's hosted on Amazon SageMaker with all the details from that play, the game situation up until that point. And this is a very low latency system, so you can get up to 780 predictions in a second. Of course, they only get it for 20 different lead distances from 0 to 20, and they keep these buffered, and then these probabilities, they're used to render the likelihood of successfully stealing in real time. So you, as the runner hovers away from the bag, you can see that probability change. So with this insight, let's take a look at another example.
He gets a short lead, and when you have this short of a lead, the percentages are 67% from that spot that he's going to make it. Well, Joe, what are you looking for? 75 or above from Major League Baseball, and then you say, hey, we got a chance to steal that bag. I want a 75% chance. As you see here, it starts at 63. He extends to his maximum lead. It's going to be 67%. You got no shot. You got a left-handed pitcher. Nobody runs on why because he's so quick, and a catcher that gets rid of the ball quick. You're done. So situation, the pitcher on the mound, and being able to run on the catcher, none of those things were applied in this. So it wasn't a very wise decision. And so a lot of times.
So building on the success of stolen base success probability, we've launched many more new stats. For example, we launched Shift Impact, which predicts the impact of infielder movements on a batter's grounded ball batting average, as well as matchup analysis. And these stats have been very well received by baseball fans, and it got the best broadcast Innovation of 2018 award. And there's also a tweet from Bill James from Sabermetrics on how much he loved this broadcast. So to learn more about what we've done here, you can check out this website. So I went over a number of use cases that we've been doing with sports, and sports is really a fantastic medium to bring the benefits of machine learning to life. And on account of our success with these sports organizations, we're really seeing a lot more both customers from both sports and beyond flock to AWS for their AI ML needs. And the way you can get started on your machine learning journey is, we start always with the business problems, map them to machine learning problems, and then make sure we have the right data assets to support them. We have a very broad and deep portfolio of machine learning services on AWS that can support the development of these. And it all boils down to finding the right team, the right cross-functional team of stakeholders. And the Amazon Machine Learning Solutions Lab closely partners with customers, and I'd love to talk to you about how we could help your use cases. We have very many customers using AWS for their machine learning needs, and again, it's finding the right folks, having the right data strategy, and then organizing for success. So the way we think about our machine learning stack is like a 3-layered cake. So at the lowest level is our machine learning framework. So these are our P2 and P3 instances that come pre-installed with all popular deep learning frameworks. You know, we really believe in giving the widest choice and giving scientists and developers the right tool for each job. So for example, we support TensorFlow. 85% of all TensorFlow running in the cloud runs on AWS. We support PyTorch. 83% of all PyTorch running in the cloud runs on AWS. So we find that you know, scientists and researchers like to work at this framework level. One layer up is Amazon SageMaker, which is our flagship platform. It's a fully managed machine learning platform that removes all the heavy lifting from model training, deployment, monitoring, and it can really help organizations do machine learning in a very expansive way, and it puts ML in the hands of every data scientist and developer. One layer above that is our API level services. So we've got services for computer vision, like recognition. We've got services for NLP and for speech. And all of these services make machine learning just one API call away. So developers can really build applications infused with machine learning with just simple API calls. And you know, over time, we envision our customers using all 3 layers of these stacks and different aspects of them and integrating across these. So again, you know, the Amazon Machine Learning Solutions Lab, my team, as I mentioned, we work with our customers, we brainstorm and ideate with you, we identify high impact use cases that we can partner with you on, and we help take your ideas all the way to prototypes and also to production. So to learn more about you know, our services, you can visit this website. So thank you all, and you know, I will be available on the side if you have any questions.